invited me. I got a lot of stuff. I'll go through this quick. I know you guys want to go to lunch. I seem to have... Hello? Oh, there. Anyways, my project I've been working on the last couple of years was funded through the NRCS as a CIG project. Had two main objectives and quite a few partners from up in my neck of the woods, Montana, Wyoming, South Dakota primarily. Actually, we intended to start in 2010. We had a little flood problem up in that neck of the woods in 2011, so all of our field work got delayed until 2012. That's just a quick overview. We had two main objectives. One of the things I found that there were a lot of groups doing riparian management focusing on Saltcedar and Russian olive up in our neck of the woods and all the watersheds. And one thing that became perfectly clear is nobody seemed to have a very good understanding on what the plant community response was over those variety of management efforts. And the second objective that I wanted to really look at was one of the big critical sort of challenges or obstacle courses to deal with is what do you do with the biomass you create when you do these removal projects. Objective one, I'm just kind of going to quickly go over this before I get into it just to give you an overview. Like I say, the objective one, we put in permanent transects on all our project sites to develop the baseline vegetative data over all the project sites. We had a good understanding what was there before we initiated any of the removal management stuff. And then what we do in year 2 and year 3, once we do the initial removal and treatments, we go back and do those vegetative surveys every year, the first 3 years. So we get a really good detailed understanding of what's going on in that overall vegetative community process. As you can see, there's a regional overview. I've got 9 project sites. They're all approximately 14 to 15 acres in size, so we wanted that real consistent. Some of the project sites were natural areas, some were agricultural, riparian grazed areas. This is a picture here where we're setting up our initial transects and doing the veg surveys. This is one interesting site, and I just threw this in there. One of our project sites in northern Wyoming is in a wildlife habitat area. And they've been doing a lot of Russian olive saltcedar management work for the last 7, 8 years, but their process was a little different than what I thought was pretty effective. They've been going in there and doing mechanical mastication with no follow-up herbicide treatments until the following season, which in my book looked like a recipe for disaster. And so what we wanted to do was put our project site in where we came in and did very prescriptive mechanical removal, stump treatments immediate after the cutting, and compare it to their mastication work. The only problem with that process was this summer after the first year of work when we had the baseline data, as you can see in the pictures on the right, there was a rangeland fire and it burned through the whole system. So not really sure what we're going to learn. I threw this slide in here just to kind of show you what the percentage of cover was. A lot of the project sites were 70 to 80%. So we were dealing with some pretty tough stuff. Here's a picture site of one of our project areas over outside of Sturgis, South Dakota. As you can see, a pretty dramatic difference once we did those mechanical removals and did the stump treatments. Like I say, that's a quick overview. The costs on the Russian olive saltcedar treatments average between $1,000 and $2,000 an acre. We contracted that out with commercial vendors. And then in the year 2, we did chemical spot treatments on the regrowth, and that averaged out to about $240 an acre. Very effective. This is just a picture of one of the saltcedar sites that we worked on. Of course, we went in and did basil bark treatments with backpacks, triclopyr basil oil mixtures, saw 95% control one treatment, and we came back in year 2 and just did spot treatments on any of the regrowth. That's a picture of that, what that site looks like about 30 days after treatment. This is just kind of some more overview stuff. This is another landowner site that I thought was kind of interesting. Massive amount of grass regrowth in there, and this is the site that had about 90% cover of Russian olive, so it was incredible. But we really wanted to understand what the natural vegetative response is over the site. So I thought this is really critical stuff that we're going to learn that will help people develop restoration strategies. And this is just a picture of one of the sites to give you an idea of the amount of biomass generated on a 14-acre site. This is something that came up last year too. One of the big questions was with these Russian olive Saltcedar things was the convention was with Russian olive seed length viability. Well, the conventions I'd always worked from, they believe were about 4 or 5 years. Some of the regional plant material centers, as you can see this data on this slide, that turns out to be, that doesn't look to be the case. As you can see, some of those test slide or retesting that was done last year looks like there's a lot of 50 to 70% seed viability 20 years out. So I think that's going to change how we look at management strategies. Like I say, that's kind of the management side of this. Now I want to jump into the bioenergy thing that's probably of more interest to you guys. I'm a weeds guy. Most of you guys are weeds guys, so I wasn't a bioenergy guy, so I spent about 2 years really diving into this. But one of the things I figured that this big challenge is, what do we do with this biomass? The convention always was slash pile, burn it on site, and deal with restoration later. So I thought to myself, there's got to be a better way. So I kind of got into bed, so to speak, with a lot of the regional forestry folks who have been using woody biomass as an alternative fuel source. And I thought, why can't we be replicating the same work they've done in the national forest system? So I set upon finding labs and talking to experts all across the country to do the testing to look at the feasibility as a fuel source with Russian olive and Saltcedar. And as you can see on this slide, the BTU values of these two species is almost identical with the conifer stuff that they've used in bioenergy for the last couple of decades. Makes a lot of sense to me. This is some of the other stuff we looked at. That's just basic BTU values over that. Like I say, they're right in the ballpark. Looks like a really good feasible product. One of the other things that they really look for as far as a high-value bioenergy source is the ash content that's produced when you burn that material. So I had the labs do some additional constituent testing because I had concerns that there may be some constituents in there that might make this problematic. And as you can see on this slide, Saltcedar especially has elevated levels of potassium, sulfur, and phosphorus. Not the worst thing in the world. The upside of that I learned about this thing that's kind of cool is that kind of makes that stuff really good materials that you could use in a biochar process and use that as a soil amendment for restoration, like especially in these bird forestry areas where they're trying to do reclamation. This slide here just has some basic comparative costs of the fossil fuel stuff. Unfortunately, in this part of the country, a lot of coal production, a lot of natural gas. We're competing with some pretty big dogs economically, but it just makes a lot of sense to me. After I started meeting with some facility managers, especially in western Montana, who had been using this biomass as an alternative fuel source, like Western Montana College, they'd had this system in place for 10 years. They got a federal forest grant to cover some of the costs for the installation and the conversion, but they figure now they're saving the taxpayers about $80,000 a year versus what they'd be paying in fossil fuel costs. So I think over the course of about 8 to 10 years, you've paid for that conversion, and it's a great way to get off that fossil fuel kick. And over there, we've got lots of forest land, so we've got a lot of biomass we need to get rid of anyway. And one of the other things that you learn in this bioenergy deal is find experts who really understand the game. So Tom Miles is a consultant who does bioenergy consultation and analysis for forestry all over the country. I had Tom do an independent assessment of all our work. The copy of the report is actually on there. Really good information, covers this in much more detail. I think it's just a great alternative objective or idea or concept that really we could apply here, that really gives us another PR value to say, not only ecologically do we need to be dealing with this riparian restoration, but what could we do with this biomass above and beyond the standard slash pile, burn, and restore. So that's kind of where it's at. I wanted to say we have a great website that has all the project information you'd ever want. I could keep you reading for the next 5 years. I actually printed out some fact sheets here on the project. It's got the website link, all the project summary information on there. You're welcome to come up and get those. Any questions? I know I'll be around if you guys have anything. I kind of went over this super quick because I know we were in a time crunch. But anyways, I think it's an idea that you guys could conceive of down here because it seems like a perfect fit. Thanks.